Hi, welcome to the next lesson of this streaming introduction part, where we are going to see different transformations. I think that this you already know, the data is messy and very often needs to be transformed in order to give a better insight to the end users. And streaming processing is not different. Here too you can apply different transformations for different purposes. And the first family of transformations, I called it the simple transformations because they work, well, they are quite rudimentary. So the first one is the filtering, meaning that if we want to eliminate some records, some events that don't correspond to our expectations. So for me, it was the yellow color. And yeah, that's the purpose. The second one is the mapping. So we take one data, we transform it into a different format, or maybe we add some extra information to the existing one. So here I'm doing this with the circles, and the purpose is to adapt the input to the expected output. So for example, if we are getting some proprietary input data in binary format, and we want to avoid all our consumers to parse this data into some much more easier format to live with, well, we can do some mapping in the data cleansing job and, for example, convert it into an open source binary format like protobuf or Apache Avro, or even to JSON if you want. A small variation for the map is the flat map, because here from a single element we are generating one or multiple ones. So here again this purpose is the same, but it's just the output that differs. And that was for the first family. The second family is for the partition based transformations. And here the idea is to apply some of the simple transformations on top of a bunch of records living in the same processing partition. So here we can see that we have the map partition functions, where we will take all elements from the partition and apply the map function to them at once and not one by one as in the previous simple transformations part. And it can be good because if your mapping relies on some external data, here you can, for example, optimize the number of connections and open only one connection per partition, or you can even reduce the number of calls if you have the same information required in by each partition by simply caching it or making a fetch before the mapping. Another variation for that is the for each partition. For each partition works again in a partition basis, but it doesn't have any output information. So it can be an operation that either implement some custom thing that is not supported natively by your data processing framework, or it can be also a silent consumer that maybe detects some errors, raises an exception when there is something unexpected in the data. So here the key part is that the key part to remember is that we can apply some custom processing logic, and the output, the function doesn't need to write data somewhere. For the next family, we have the grouping transformation. So the grouping transformation operate on data which is keyed. So it's exactly like for SQL statement where you would do some select from and you do group by, and in your select you can do some counts on these groups or any other interesting transformations or aggregations. So here the first thing is to group by key with the goal to bring the same elements, the related elements, to the same processing partition, so that you can, for example, later apply a common mapping function on them or do any other processing you want. After that, there is aggregation. So it starts with the same idea of bringing the data to the same partition, but here we have the specific purpose, which is the aggregation, like for example counts or sums or averages. There's also map groups. So here again, it's kind of specialized, or maybe the follow-up for the group by in the previous slides, from the previous slide. So here we are grouping data in the same partitions and transforming them into something different. So the purpose is exactly that, transform items of the group. So the purpose of that is to transforming items of one group sharing the same key. And if you think that the group transformations are the complex one, or maybe the most challenging, you're maybe not fully, you may be a little bit wrong, because there are combinational transformations that are also quite challenging to work with. And the first of them is join. So join takes data from two different streams and combines them into a single, I would say, processing row, the same partition. And yeah, the purpose is just the combination of different events, or maybe the correlation. For example, I think the very frequent example for this transformation is that for one stream you have the ad impressions, and in the second one you have the clicks on these ads. And if you want to get some interesting insight, well, the best is to combine both and see maybe the click ratio and stuff like that. And the nice thing is that you can combine the join not only with two different streaming sources, but you can also combine the streaming source with the batch source with exactly the same purpose. But obviously, since the data address is rather slower, or changes rather much more slower than the streaming data source, well, the data may be not up to date for this kind of join. And the combinational transformations are challenging, but the stateful transformations are challenging too, because generally they involve an extra component of the state store, where we store the state of the application for the data we have seen so far. So here we are receiving one new record, and in the processing function we combine this record with two records that are present in this state store. Here, typically in this example, we are generating some windows, and in the windows we're counting the number of elements. So yeah, that's the purpose. And there is also much more challenging, I would say, variation with the arbitrary stateful processing, where it's up to you to define the outcome. So previously you saw we had a window, we applied some count on top of it, and here that's really our role to define what we are going to do with this data that is mixed between from real-time and state storage. Typically here we are doing a sample mapping, but I think that once you implement your first arbitrary stateful processing pipeline, you will see that it's not always that sample. And that's all for this lesson. I will complete this one with some demos, and I think that after these demos you will see much better these different transformations that are available for streaming frameworks. Thanks for watching, and see you in the next lesson.